Good morning. As the chill sets in and leaves fall, everyone's asking, will this winter be harsh or mild? Forecasting months ahead is tricky, but by piecing together global clues, we can sketch out what winter 2025-26 might bring. Our ninth update shows the odds. 52% for a colder than average winter, 48% for a milder one, a real toss-up. We analyze everything from ocean temperatures to Siberian snow and even the stratosphere. Some signals point to cold and snow, others to mild, wet Atlantic winds. Over the next few minutes we'll break down the key evidence: hurricanes, La Niña, and dramatic stratospheric events. Let's dive in and see what's in store. What do hurricanes have to do with winter? More than you'd think. The Atlantic hurricane season releases huge amounts of heat and moisture, altering atmospheric patterns for months. This energy can shift the jet stream, sometimes making it wavier and allowing Arctic air to plunge south. We measure hurricane season energy with accumulated cyclone energy, or ACE. High ACE years can sometimes precede cold winters, but not always. Other factors matter too. By comparing past high ACE years, we look for patterns. Did those winters turn out cold or mild? It's not a perfect predictor, but it's a key piece of the long-range forecasting puzzle. Historical analogs help us weigh the odds for the coming season. The 2025 Atlantic hurricane season was active. 13 tropical storms, 5 hurricanes, 4 of them major. The ACE value hit 132.6, above the average of 120. Looking back, some high ACE years led to cold winters like 2008-09 and 2012-13, but others were mild, such as 2019-20. The overall pattern from these analogs slightly favors a mild westerly-driven winter, especially in December and February. So, while the hurricane season was energetic, history suggests it's not a guarantee of cold. Other atmospheric drivers can override this signal. The takeaway: hurricane activity is just one piece of a much larger puzzle. We need more evidence to tip the balance. Now, let's look high above us at the Polar Vortex, a spinning mass of cold air in the stratosphere over the North Pole. When strong, it locks cold air up north and brings milder winters to us. But if it weakens or gets disrupted by sudden stratospheric warming, SSW, Arctic air, can spill south, triggering cold snaps. SSW events can split or distort the vortex, letting frigid air reach Europe and North America. These disruptions often lead to our most memorable cold spells. A stable vortex means mild, a weak, wobbly one means cold as possible. That's why forecasters watch the stratosphere so closely. Early signs of instability are a red flag for potential cold outbreaks. The polar vortex is a powerful tool for predicting winter's mood. As of late November 2025, the stratosphere is showing unusual and intriguing signs, signals that have caught the attention of meteorologists and climate scientists around the world. High above the Earth's surface, in the thin, frigid air of the stratosphere, subtle shifts can foreshadow dramatic changes in our weather below. A significant warming event is underway, but this time, it's starting lower in the atmosphere than we typically see. This anomaly is raising eyebrows, as it could have far-reaching consequences for the coming winter. Temperatures are soaring to about 13 degrees Celsius above normal at the 30 HPA level, driven by a powerful and persistent Siberian weather system. This is not just a minor blip. Such a dramatic spike is rare, and signals a major atmospheric disturbance. The polar vortex, a swirling mass of cold air that usually sits over the Arctic, is being displaced toward Europe. Forecast models now suggest its winds could even briefly reverse direction, a phenomenon that can trigger extreme weather events. If this happens, it could mark the earliest sudden stratospheric warming, or SSW, ever recorded in modern meteorological history. While this event is expected to be brief, the polar vortex will remain weaker than average for weeks to come, making it more susceptible to further disruptions. A weakened vortex is far more vulnerable to being disturbed again later in the winter, increasing the risk of more significant weather shifts. Some long-range models are already hinting at the possibility of a much larger SSW event developing in late December or January, which could have even greater impacts. This early instability in the stratosphere is a clear signal that the atmosphere is primed for action, setting the stage for a potentially turbulent winter season. Even if this first event turns out to be relatively minor, it paves the way for possible cold air outbreaks and sudden weather changes across Europe and beyond. The timing and strength of future disruptions will be crucial in determining how winter unfolds, and meteorologists are watching closely for any new developments. For now, the stratosphere is sending a strong and unmistakable early warning. This winter could be one for the record books, and we should be prepared for whatever comes next. In addition to tracking daily weather, meteorologists closely monitor several key climate indices that help us understand and predict broader atmospheric patterns. Three of the most important are the Arctic Oscillation, or AO, the North Atlantic Oscillation known as NAO, and the Quasi-Biennial Oscillation, or QBO. These indices act like fingerprints of the atmosphere, revealing how air masses and winds are behaving on a large scale. When the AO and NAO are in their positive phases, we typically see strong westerly winds sweeping across the North Atlantic. This setup brings milder, wetter weather to much of Europe, with frequent rain and fewer cold snaps. Streets stay wet, and winter feels less harsh. But when these indices flip negative, the story changes. High-pressure systems can block the usual flow, allowing cold air to spill down from the north or east. This can lead to outbreaks of snow, icy winds, and prolonged cold spells, especially across northern and central Europe. At the moment, the AO is in a positive phase, but forecast models suggest it may soon dip into negative territory. This shift could open the door to more wintry conditions. Meanwhile, the Ndaisotekomaitsen Obimba, Misombaikakladidzususkendaitsen to the Maitsen DNAO, is currently weakly negative, but both indices are expected to return to more neutral values in the near future, signaling a period of transition and uncertainty. This mixed or neutral state means the atmosphere isn't locked into a single pattern. Instead, we can expect a variety of weather, mild spells, but also the potential for sudden cold snaps and wintry surprises. Another crucial player is the QBO, a stratospheric wind pattern above the equator that flips direction roughly every 2 years. This winter, the QBO is in its easterly phase, which can have far-reaching effects on the polar atmosphere. An easterly QBO tends to weaken the polar vortex, making it more likely for sudden stratospheric warming events to occur. These events can disrupt the usual flow of air and trigger cold outbreaks at the surface. With this background state, the atmosphere is primed for blocking patterns and the potential for significant cold weather episodes, especially if other factors align. While these indices don't guarantee a cold winter, they certainly keep the door open for dramatic shifts. The weather can swing quickly from mild to wintry, so it pays to stay alert. That's why we're constantly monitoring these signals, watching for any subtle shift that could tip the balance and bring a change in the season's weather story. Oceans are not just vast bodies of water. They are the planet's memory banks, storing heat and shaping our weather for months, even years at a time. The surface may look calm, but beneath, powerful currents and temperature shifts are constantly at work, influencing everything from local storms to global climate patterns. This winter, all eyes are on the Pacific, where La Niña is developing. Cooler waters are spreading across the equator, and the Southern Oscillation Index is strongly positive. Classic signs of La Niña's growing influence. Meteorologists are tracking these changes closely, as they can set the stage for dramatic shifts in weather across continents. La Niña winters often bring colder and sometimes snowier conditions, especially as the season progresses. This happens because La Niña encourages blocking highs in the North Atlantic, which can lock in cold air and create persistent wintry patterns over Europe and North America. The North Atlantic is running warmer than average overall, but there's a tripole pattern emerging. Warmer waters south of Greenland, cooler patches off the US coast. This setup can support the kind of atmospheric blocking that favors cold spells, especially when combined with La Niña's effects. Meanwhile, the North Pacific remains cool, reinforcing a pattern that can help steer the jet stream southward. This often means a greater chance for cold air to spill into Europe, increasing the likelihood of chilly outbreaks. The Indian Ocean dipole, which was negative earlier, is now weakening and returning to neutral. This shift means it will have less of an impact on the global weather stage, allowing the Pacific and Atlantic signals to dominate the outlook. Taking all these signals together, the message from the oceans is clear. La Niña is tilting the odds toward a colder winter, especially for Europe and parts of North America. The interplay of ocean temperatures and atmospheric patterns is stacking the deck in favor of more frequent cold spells. However, the unusually warm North Atlantic could act as a buffer, moderating some of the cold and bringing occasional milder spells, especially near the coasts. This warmth may prevent the cold from becoming too persistent or severe in some regions. The ocean's memory is long, and its influence is strong. Changes in ocean temperatures today can echo through the atmosphere for months, shaping the weather we experience far from the sea. That's why meteorologists pay such close attention to these patterns. They are the foundation of our winter outlook, offering clues about what's to come. The balance of signals is still delicate, and small changes in the oceans can tip the scales. As we watch the seas, we're watching the future of our winter unfold. Snow cover in Siberia and Scandinavia is another big winter clue. Fast, widespread snow buildup cools the air and strengthens the Siberian high, which can weaken the polar vortex and trigger SSW events. This year, Scandinavia's snow is impressive, matching years with notable cold spells. But Siberian snow growth is lagging, which could limit the strength of the Siberian high. Historical analogs show years like 2010 brought cold Decembers and Januaries, but milder Februaries. The current snow pattern suggests a cold start to winter, but the signal weakens later. Snow cover is a key factor, but not the only one. The interplay with other signals will decide the outcome. So, what's the bottom line for winter 2025-26? The forecast is finely balanced: 52% cold, 48% mild, strong cold signals, developing La Niña, easterly QBO, unstable stratosphere, and rapid Scandinavian snow growth, but mild signals remain: historical hurricane analogs, slow Siberian snow, and a warm North Atlantic. Expect a winter of contrasts. Significant cold and snowy spells are likely, especially early on, but milder, wetter periods will also occur. The polar vortex's behavior in the coming weeks is crucial. A major SSW in December or January would tip the scales toward a cold outbreak. Prepare for swings between cold and mild, not a winter stuck in one mode. Stay tuned for updates as the season unfolds. The story isn't finished yet. Winter's outcome will be decided by the atmosphere's next moves.